This graph is then used to calculate a reference circle and its deviation from reference roundness. The least square reference circle, the most commonly used reference circle, is a circle that equally divides the area between the inside and outside of the reference circle. Out of roundness is then presented in terms of the maximum displacement from the reference circle, the difference between the highest peak to the lowest valley. A minimum zone reference circle is derived by first calculating the smallest circle that can fit inside of the measured data. Next, the smallest circle that can encompass the measured data is calculated. The out of roundness is given by the radial separation between these two circles that enclose the data. A minimum circumscribed reference circle, sometimes known as the ring gauge reference circle, is the smallest circle that totally encloses the data. Out of roundness is quantified as the largest deviation from this circle. A maximum inscribed reference circle is the largest circle that can be enclosed by the data. The out of roundness is quantified as the maximum deviation of the data from this circle. This is sometimes known as the plug gauge reference circle.
Roundness is sometimes referred to as circularity. What we shall first do is take an out of round part, and then we'll find the centre of rotation, or the axes of rotation. This is sometimes quite difficult to find, since we have to find the least squares best fits a circle. Then from that least square best fits circle, calculate out the centre of rotation. We then rotate about this centre of rotation, and with a dial indicator we'll measure the roundness. As we rotate the part, the total indicator reading is our roundness value. And providing that our total indicator reading does not go outside of our tolerance zone of 0.005, then the part can be considered as in tolerance. If it goes outside of this tolerance zone, then the part is out of round. Now let's take a look at how we'd inspect roundness in our readout. Our readout is not the ideal solution for measuring roundness, but by taking as many points as possible, it can give us a reasonable good idea of our roundness value of a circle measured. To do this, we need to take as many points as possible. So I'll click on my cross lines, I'll go to Tool Options, and I'll change my maximum circle points to 99, then push Finish. Then I'll click on my cross lines once more, and I'll select Multi-Edge. Then I'll select Circle. Now since my middle circle here takes up less than 75% of the field of view, I can just simply push the Enter button to take my points. Now I can go to the View tab and view my roundness. This is my out of round in my view window. F, which stands for form, is the out of round value. Now what I can do is I can go to Tolerance, and I can click on the roundness tolerance and enter in a value. I shall enter in 1 millimeter. And push Finish. The little green square next to my circle shows that this has passed tolerance. This is how to inspect roundness in the readout.
Hello, today we're demonstrating the Roundness RS300 and some of the CNC capabilities. This machine has the ActiPro software, which will be running and managing this machine. From here we move into a part alignment. The Roundness 100 is a manual alignment, but the Roundness 200 and 300 series have automatic programmable alignment for centering and tilting with a wide range. The first thing that we will do here is we will pick a point at the lower extremity of the workpiece and one towards the top of the workpiece. As you can see on the screen here, we have an alignment box. From here we was able to choose the amount of eccentricity as a target for the alignment, so we're able to fine-tune the amount of alignment that we want. This machine also features the air bearing table, allows for high accuracy, low maintenance wear. We also have the exclusive rotary glass scale in the table. These are all modular machines and are very good solutions for shop floor or lab use. Once eccentricity has been reached on upper and lower levels, the machine will move into measuring position. From here you can see that we do have our high resolution, adjustable force, and limited for notching detector. We also have high accuracy column and ceramic radial arm for accuracy and setting datums in both axes. We also feature a real-time display so you can see the measurement as it takes place to understand what your measurements may look like as it is being measured. We have the ability for R-axis tracking. So as this machine moves forward to take the measurement, as you look between your indicator for your stylus and the motion, you can actually see the R-axis moving to follow to keep your stylus in the center of the range. On the next 300 model, we also have the ability to rotate the stylus to keep it normal to the surface with a motorized CNC head. From here you can see that we are able to rotate and choose a range of degree, keep the stylus normal to the surface. With a CNC motorized head, we're also able to measure in ID, OD, upper face and lower face. So even if you only have a couple directions, this may be a great solution for you to where your operator does not have to come back and change direction of a probe in order to complete a measurement. It is fully programmable for multiple directions, even if it is only one or two. That way there is less operator interference and quicker measuring cycle times. From here we are taking a flatness trace on the top of the workpiece, and from here we move to the inside and do an ID measurement. The ActiPro software comes equipped with the latest standards and settings for form and finish measurements. ActiPro also has the ability to find edges of workpieces to form a part coordinate in R or Z axis. From here we will move back to a safe position, load unload position, for the operator to be able to load the next workpiece. Upon completion of our measurement process in the CNC program that we have selected, the report is automatically generated. The reports are fully customizable. You can put your company logo, your measurement information, date, time, what type of measurement cutoffs, whatever you want to use. The information that we had the operator input at the beginning of the program appears here. If we look at some of the measurements that we have performed today, we have our outer diameter cylindricity. We show it here in a 2D plane, also in a 3D plane. We can also at any time adjust this 3D plane to see the optimal view from a three-dimensional standpoint. Also, we have measured the cone roundness. This is when we turn the stylus at an angle normal to our surface. This is our bore ID roundness. Also, we look at our top plane flatness. We can see the flatness and the values there as well. And from here, we will also measure coaxiality at a couple different points here and able to do that in the report all at once. Also, from our two traces that we took across the cone, R-axis tracking, we was able to evaluate straightness on both sides of it. And also we was able to compare those two straightnesses for a taper, where we, in this case, we show an included taper of almost 37 degrees. ActiPro software is very easy to use. For example, if I had the need, I could come up and pick some different datum points and do a new analysis, a rotary analysis. Maybe I want to do a squareness. I can choose all of my outer diameter as my datum, and I can choose the top face. Next, I choose my point of datum, the outer diameter, okay. And just like that, I have created a new analysis. So once the data is taken, it is easy to add or take away from your report and have the information that you need. Again, if you're looking for a modular system, the Roundcom Next RS300 with a full CNC head is a great solution for multi-directional cylindrical measurements.